Hi everyone, so today we're going to go ahead and use inverse trig functions and perform compositions of these trig functions. So there are several types of problems that you can encounter with compositions of trig functions as well as their inverse. So it is possible to have two functions that are direct inverses of each other. So think back to when you first learned about inverse functions, and when you did the compositions, they both happened to equal x. So you can use this same sort of inverse property when you have trig functions. And sometimes the answer might be in the problem, and then other times you might have to do some renaming. You do have to be careful with restrictions on arcsine and arccosine, and you'll look at arctangent when you get to calculus. So if the arc function is in the inside, what you're going to do is you're going to think about the domain. So if the number is in the domain, then that is your answer. But if the number is not in the domain, then there's no solution. So we want to think about that the domain for arcsine and arccosine is from -1 to +1. So if I look at this first question, my arcsine is in the inside. So I'm looking at 0.5 and I want to see if whether or not that 0.5 is in my domain. So I know it is in my domain, so then my number is my answer, so 0.5. In letter B, we're looking at the square root of 2 over 2. And again, we're looking to see if that is in between -1 and +1, which it is. So then my answer is just going to be that number. So in letter C, my inverse function is in the inside. So I'm thinking about domain and looking at -2/5, and it is part of my domain, so that number is my answer. And in letter D, we're looking at 2. Now 2 is not in the domain, so there's not going to be a solution. So with your arc function being on the outside, you then have to think about its range. So when you're looking at, again, the arc sine, that is going to have a -π/2 to a +π/2. If you think about arc cosine, that range is going to be 0 to pi. So then you can think about this. You can think about if your angle is in the range, then that's the answer. If your angle is not in the range, you need to sort of rename it to the corresponding angle that happens to be in the range. And what we mean by corresponding angle is that you're also looking at where is it in the same angle location, but within that range. So again, you can memorize this rule, memorize the previous rule, or you can figure out like what's in the inside and then think about the function that's on the outside. So in letter E, our arc function is on the outside. So we're going to think about whether or not my π/2 is in the range for arc cosine. So it is. It checks out. So my answer is π/2. So in letter F, our 3π/4 does not fit in that range. So you want to think about, okay, where is that corresponding angle? So if I think about arcsine in quadrants 1 and 4, and I know that 3π/4 is here in quadrant 2, so the corresponding angle that would be in my range would be in quadrant 1 here, and that would be π/4. So what you can also think about is doing this question and thinking about taking care of the inside and then looking at the outside. So if I think about the inside function, I'm looking at sine of 3π/4. So sine of 3π/4 I know is √2 over 2. So then if I think about arcsine of √2 over 2, I can think about, okay, the sine of some angle is going to be √2 over 2, and I know that that's going to be in quadrant 1, which would be π/4. Okay, so in letter G, if I look at 5π, I am not in my range for arcsine, so I know that 5π would technically be right over here. So in order for me to figure out what my angle would be, I'm going to go ahead and see, all right, where would that corresponding angle be that is actually in my range, which would be here, and that would be 0. Or again, you can think about this same question and work with the inside first and then look at the outside. So sine of 5 pi is 0. And if I ask myself, okay, the arc sine of 0. So the sine of some angle is going to get me 0, right? So that's my y value. So again, I think about in my range, what would that be? And that would be at 0. Okay, so the next question, what you have is 5 pi over 4. Again, now 5 pi over 4 is not in my range. I know that 5 pi over 4 is right here, right? Because my cosine range is 0 to pi. Okay, but then I want to think about, okay, well, what would be this corresponding angle that happens to fall in my range? So it's actually going to be over here. So that angle is 3 pi over 4. And again, the second way to do this, you can think about inside and then outside. So if I look at my question again, I'm trying to figure out, okay, so the cosine of 5 pi over 4, that is negative root 2 over 2. So then I'm thinking about the cosine of some angle is going to be negative root 2 over 2. So when I think about, okay, in my range, what would that angle be? That would be a cosine of negative root 2 over 2. And that would, again, be 3 pi over 4. So notice, again, two ways that you can do this question. If you're going to be able to remember the rules, that'd be great for you to go ahead and use those. If not, you can think about figuring out what's the inside and then what's figuring out the outside. Okay, so there are times when you might be given two functions that are not direct inverses of each other. So that means I don't have sine and inverse sine. And let's say the ratio is not on your unit circle. So what you're going to do is you're just going to go ahead and draw a right triangle. So again, I want to think about this inside and figure out, okay, where would that be in my quadrants? So I know that if I have the inverse sine, I know that I need to be in either quadrant 1 or quadrant 4. And then I'm asking myself, the sine of something is going to get me negative 4 over 5. So when I think about my y value being negative, I'm actually going to be in quadrant number 4. So then sine is opposite. So I got negative 4 over 5. So then I figure out my triangle. I know this is a 3, 4, 5 triangle, so my missing side is going to be a length of 3. And using that, you could figure out what secant is. So the secant of some angle is going to be what? So secant I know is h over a. It's the reciprocal of cosine. So I look at my angle and I see 3 over 5. Okay, in letter B, let's go ahead and think about the inside. So let's figure out where I would be. The inverse cosine, I'm going to be in quadrants either 1 or 2. So I think the cosine of some angle is going to be negative 2 over 3. So cosine is x, so I know my triangle is going to be in quadrant number 2. Cosine is adjacent over hypotenuse, which would be negative 2 over 3. You are able to then figure out what's your missing side using your Pythagorean theorem, which would be the square root of 5. And then you can figure out, okay, the outside function we have is sine. So the sine of theta is going to be O over H, which would be square root of 5 over 3. So there are also times when your two functions are not direct inverses of each other, but then your ratio is on the unit circle. So in that case, you can again use a right triangle, or you can use your unit circle. So we're going to go ahead and show you both ways of how to answer this question. So let's look at unit circle first. So the thing that I can look at is, again, my inside. So I'm thinking about, okay, so the sine of something is going to be a negative 1 over 2. So then I know based on my unit circle, and I know that sine has to be in quadrants 1 or 4, that angle is going to be right here. So again, this is going to be a negative pi over 6. So it's not 11 pi over 6 because that's not going to fit in your range. So you have to think about going in the sort of negative direction, or you can think about it's being your negative coterminal angle. Now you have secant, so now we're going to say, all right, well, let's figure out what's the secant of negative pi over 6. So my terminal point we have is negative root 3 over 2 and a negative 1/2. So secant, I know, is going to be 2 over root 3 because it is the reciprocal of my x. When you're looking then at this question, you can go ahead and think about, okay, I want to figure out what my triangle is. So my triangle, again, taking that same sort of method as we did before, we can figure out that I know I have to be in quadrants 1 or 4. So then I'm thinking about sine being negative. So I would label negative 1 over 2, which would then lead me to get square root of 3 as my missing side, again doing Pythagorean theorem. So now when I think about secant, I'm thinking about h over a, which would then lead me to get 2 over root 3, which is the same answer as what we got. Okay, so in letter B, we can go ahead and, again, work at the inside. So we've got the cosine of some angle is going to be root 2 over 2. Looking at where I have cosine, I know that we are going to look at being in quadrant number 1. So that would be pi over 4. I'm going to go ahead and figure out that my tangent, I'm going to bring down. So my answer to find the tangent of pi over 4, which I know is just y over x, would lead me to get 1. So that's using your unit circle. If you want to use your triangle, again, you can think about cosine having to be in 1 or 2, and then figuring out, okay, well, I know that cosine is going to be right in quadrant number 1 because cosine is positive. So I figure out what my missing sides are. That is adjacent, so root 2 over 2 for the hypotenuse. Okay. You are going to get the square root of 2 for your missing side. So then you think about tangent being opposite over hypotenuse, which just becomes simplified to 1. Okay, so I hope this video helped you and you're able to do your compositions with inverse trig functions. Don't forget to like or subscribe for future notifications on pre-calc videos. Thanks for watching and have a great day.